Good day viewers, welcome to PCB Study Hub YouTube channel. My name is Mr. Dio, and on today's topic we'll be treating factors and multiples of numbers. Over the course of time, we've got to find out that students, even those in SS2, SS3, still find it difficult to differentiate between HCF and LCM of numbers, or don't know how to solve factors and multiples of numbers. So this video is to help you, our viewers, to understand the principle, the simple intricates of factors and multiples of numbers, to the point that even those in primary schools will be able to understand this video. Okay, so let's dive in. Our content, we are going to be treating definition of factors, prime numbers, HCF, definition of multiples, LCM, rules of divisibility. So, what are factors of a number? Factors of a number are all numbers which can divide the given number without any remainder. Or, factors of a number are the numbers that can be multiplied together to get us that number. Okay? What is it trying to say? So here it's trying to say that factors of a number are any number that can divide a given number without any remainder, or two numbers that when you multiply them it will give us a given number. Those are the factors. Okay, let's take for instance 6. If you are looking for factors of 6, that means we are looking for numbers that can divide 6 without any remainder, meaning we'll be having 1, we'll be having 2, we'll be having 3, and we'll be having 6 itself. Or we'll look for two numbers that when you multiply it will give us 6. For example, 2 times 3 will give us 6, right? And 1 times 6 will give us 6. Now these numbers are said to be what? Factors of 6. An example like we have here now, the factors of 12 can be written as 2, 3, 4, 6, and 12. Now when you check it, when all this number divides 6, it can divide, it can divide 12 without any remainder. 1 divide 12 will give us 12, 2 divide 12 will give us 6, 3 divide 12 will give us 4, 4 divide 12 will give us 3, 6 divide 12 will give us 2, and 12 divide 12 will give us 1. Now when we go further, we will notice that every number has at least 2 factors, which is going to be what? 1 and itself. And this will bring us to our next subtopic, which is what? Prime numbers. Okay, so what are prime numbers? Prime numbers are numbers that are greater than 1 that can only be divided by 1 and itself. Let me repeat again. Prime numbers are numbers that are greater than 1 that can only be divided by 1 and itself. In this case, prime number have only two factors, okay, which usually is just 1 and itself. Any other number is no longer a prime number. Okay, now by this definition we see that what prime numbers are numbers except 1 which can be divided only by 1 and itself. Remember, we say what is going to are numbers except 1 which can be divided only by 1 and itself. Okay, here I gave an example of prime numbers from 1 to 200. We have 2, we have 3, we have 5, we have 7, we have 11, 13, 17, 19, 23, and so on and so forth. But I feel with course of time we'll be getting used to seeing this particular range of numbers here, and you should have it at the back of your mind that whenever you are solving and you see any of these numbers, at least these ones I underlined, you will notice that okay, you know that those numbers are what? Prime numbers. Nothing can divide them except 1 and itself. Okay, now if you notice from above list, 1 is not listed as a prime number. When you check here now, prime number start with 2, then start with 1. Why is that so? This is because what? From the definition we have, we say that what? we say that prime numbers are all numbers except 1, or prime numbers are numbers that are greater than 1. These 2 points brings it out. Prime numbers are numbers that are greater than 1. Prime numbers are all numbers except 1. And then the second point is what? They are divisible by what? 1 and itself. You see? This means that what? Prime numbers have 2 distinct divisors. Okay? Prime numbers have 2 distinct divisors. And by divisors, we mean that numbers that can divide other numbers. But in case of 1, there's only one number that can divide 1, which is what? 1 itself. So by definition alone, 1 doesn't qualify to be a prime number. Okay, I hope you understand that. Now here we have in construct prime numbers, we have composite numbers. These are numbers that are greater than 1 that have more than 2 divisors. Okay, so what are these composite numbers? We have defined it before. Composite numbers are numbers greater than 1 again that can be divided by what? More than 2 numbers. Example: 2, 6, 8, 9, 10, 12, and so on and so forth. Okay, from our definition again, listen, that means 1 also is not a composite number and also not a prime number. Why? Because what? Composite numbers are numbers greater than 1 and can be divided by more than 2 numbers. Okay, it is important to know that 1 is not considered a composite number because it does not have more than 1 distinct divisors. Sorry, it's supposed to be more than 2 distinct divisors. It has only 1 positive divisor, which is 1 itself. Okay, now we'll go over to the next subtopic: prime factors. We have explained prime numbers, we have explained factors. Now when you bring these 2 words together and ask what's prime factors, what does it mean? Okay, from our definition now, you see that what? Prime factors of a number are prime numbers which can divide the given number without any remainder. All right, what does this mean? This means that what? Whenever we are dividing, now the prime numbers that can divide the given number, those numbers are identified as what? Prime factor. From our previous example, we have factors of 12. We have 1, 2, 3, 4, 6, and 12. Now the prime numbers here are what? 2 and 3. So these 2 and 3 are going to be our what? Our prime factors. I hope you understand. Meaning, if you are let's assume I give you a number like 10. Factors of 10, we have 1, we have 2, 5, and 10. For the list, we know that 2 and 5 are our prime factors because only 2 and 5 that are what? Prime numbers in the factors of 10. Okay, from there we move on to what? Expressing number as a product of its prime. To express a number as a product of its prime, we use what we call prime factorization. Prime factorization is a way of breaking down numbers into its smallest prime component. This involves finding numbers that when multiplied, it will give the original number. Okay, what is this trying to say? Prime factorization is the simplest way to put it is using only prime numbers to divide a particular number until no number can divide again. Okay, by this definition, we have what? Prime factorization, breaking down numbers to its smallest prime component. Okay, to find prime factorization of a number, we can do so by dividing the numbers with the least prime number or by using factor 3. Prime factorization is unique, meaning that no matter how we divide numbers in its prime factors, the result will always remain the same. So how do we divide prime factors? We have 2 methods, like I said. Okay, let's look at the first method. For example, now we ask for express 36 as a product of its prime. First of all, we have to divide 36. Now, when we divide 36 by 2, it will give us, remember, I'm dividing with only what? Prime numbers. When we divide 36 by 2, which is a prime number, it will give us what? 18. Now, since 2 can still divide 18. We use 2 again, right? When we divide 18 with 2 by 2, it will give us what? 9. Here now, 2 can divide 9 to give us a remainder, but 3, a prime number, can divide 9. And since 3 can divide 9, 3 will divide 9 to give us what? 3. And 3 will divide itself to give us what? 1. Okay? Now when we are done, we copy out our prime factors that we have here. These are the prime factors here. We copy them out and express them as this. As what? 2 times 2 times 3 times 3 is equal to 36. If you use your calculator and type 2 times 2 times 3 times 3, it will give us what? 36. So it's either we use this method, which for me, this method I use, or we use the factor tree method. And by factor tree method, it means what? Splitting a number into 2 components until we have the least prime factors that can divide. Okay, now no matter how you do your factor tree, you always arrive at the same answer. Now when we split 36 into 2, we'll be having 4 and 9. 4 times 9 will give us 36, obviously. So when we split 13 into 2, it will give us what? 4 and 9. Now when we come to split 4 into 2, it will give us what? 2 and 2. And when we come to 9 and split 9 into 2, it will give us what? 3 and 3. And once we are done, we'll circle all the prime numbers that we have, right? We are circling 2, 2, 3, 3. So again, our answer is expressed as what? 2 times 2 times 3 times 3. Remember, we say that what? Prime factorization is unique in a way that no matter the method you use, you will always arrive at the same answer. Index form. Index form is also known as what? Exponential form or power notation. I'm very sure some of you must have heard when someone say 2 raised to power 2 or 3 raised to power 5 or 10 raised to power 10. Now that's what index form or power notation or exponential form. Okay, this is a way of expressing same numbers by multiplying them together using a base and an exponent, which is power. Okay, what does this mean? Like in our answer, we had our previous answer of prime factors of 36. We'll have 2 times 2 times 3 times 3. Now this can be written as what? 2 raised to power 2. How do you get the 2 raised to power 2? 2 is multiplying itself how many times here? 2 times, right? So we'll take the 2 and raise it to the power of itself 2, because it's multiplying itself 2 times. 3 now is what? Multiplying itself how many times? 2 times again. So we take one of the 3 and we'll raise it to the power of 2, because it's multiplying what? 2 times, right? This means that what? 2 raised to the power of 2 and 3 raised to the power of 3. Okay, which can be further explained as 2 multiplied itself 2 times and 3 multiplied itself 2 times. Index form helps us to save space and also help us to reduce errors in counting and copying numbers. Let's go for further examples. Example 1 says what? Express 88 as a product of its prime in index form. Okay, now one prime number can divide 88. We start with 2. 2 divide 88 will give us 44. 2 divide 44 will give us 22. 2 divide 22 will give us 11. One number can divide 11. Remember, 11 is a prime number. It's only 11 that can divide 11. So 11 divide 11 will give us what? 11 divide 11 will give us what? 1. So now we can express 88 as a product of its what? Its prime in index form as what? 2 times 2 times 2 times 11. When you multiply it using your calculator, we'll have 88. Now when we put this number now in index form, when we put this number now in index form, we'll have what? 2 raised to power 3 times 11. How do we get to 2 raised to power 2? 3. How many times is 2 multiplying? It's multiplying 1, it's multiplying 2, and it's multiplying 3 times. So now 2 raised to the power of 3 times 11 will give us what? 88. Example 2 says what? Express 2700 as a product of its prime. As a product of its prime and we'll still leave our answer in index form. Okay. Now we are to split the numbers. This is what factor 3 method. We are to split the numbers into 2. Remember, I told you however you split your numbers in factor 3, you will still arrive at the same answer. Okay, so you split it into, you have 2 and 1350, and you continue splitting your numbers till we have what? 25, and we split 25 into 2, we have what? 5 and 5. Right, now we are to sort circle our prime numbers. We have 2, 2, 3, 3, 3, 5 and 5. So again, our answer is expressed as what? 2 times 2 times 3 times 3 times 3 times 5 times 5. When you multiply them, it will give us 2700. Now, to convert it to index form, we'll check how many times is 2 multiplying itself. Multiplying what? 1 and 2. So you're having what? 2 raised to the power of 2, right? How many times is 3 multiplying itself? We have 1, we have 2, and we have 3. That means 3 is multiplying itself 3 times. That means we have what? 3 raised to the power of 3 times. How many times is 5 multiplying itself? We have 1, we have 2. So we have what? 5 raised to the power of 2. Okay. We'll go over to our next subtopic, highest common factors. What's highest common factors? Highest common factors refers to the largest positive number that can divide 2 or more positive numbers evenly without any remainder. Okay, let me further explain. Highest common factor, which is HCF, is the highest number that can divide 2 or more numbers evenly without any remainder. Let's assume you have to find the highest factor of what? 6 and 12. And when we list the factors of 6, we will see that we have what? 1, 2, 3 and 6 in it. And the factors of 12, we have 1, 2, 3, 4, 6 and 12. Now the highest number that can divide both of them will what? 6. So 6 is our HCF. But how do we find these highest common factors? We have 2 ways. First, the first method, we find the factors of each numbers, like I just said that previously. Now we then select all common factors of the given number. These are factors that are shared by all numbers. Then from the selected common factors, we will now select the largest common factor. All right, that's method 1. For method 2, we express all the numbers as a product of its prime factors. Then we'll find common prime factors. Then we multiply common prime factors together to give us HCF. So let's see an example to let us understand better. Example 1 says what? Let's find the HCF of what? 24 and 36. Remember, method 1 says what? First we list out the factors of each of the numbers. Factors of 24, we have 1, 2, 3, 4, 6, 8, 12 and 24. Factors of 36, we have 1, 2, 3, 4, 6, 9, 12, 18 and what? 36. So now we list what? We list our common factors. And how do we get our common factors? Common factors are numbers that appear in both what? 24 and 36. So we select 1 appeared in both of them. We'll have our 1 here, right? Now we select again 2 appeared in both of them. We have our 2. We select again 3 appeared in both of them. We have our 3, right? 4 again. We have our 4, 6. We have our 6 and what? 12. And what? 12. Now these are our common factors. From the list of common factors, we select the highest number, and the highest number here is what? 12. So 12 is our HCF. So is either we'll do this or we'll use second method, which is what? First we will express the numbers as a product of its prime. Okay, that's we do prime factorization for each of the numbers. So if you have to express 24 as a product of its prime, you're having what? 2 times 2 times 2 times 3. And if you have to express 36 as a product of its prime, you're having what? 2 times 2 times 3 times 3. Now we select all common prime factors. We have 2 and 2 here. We have 2 and 2 here again. And now we have 3 and 3. Now our common prime factors are what? 2 times 2 times 3. Now we multiply them together. 2 times 2 will give us 4. 4 times 3 will give us 12. And we have our answer. So I have my own method, my personal method. I call it the bonus method. Okay, I use this method personally because it works for me and it's faster. Okay, what was this personal method? What was this bonus method? It says what? To find HCF of numbers, first we divide all the numbers with a common prime factor till no common prime factor can divide again. Okay, you divide the numbers with a common prime factor till no common prime factor can divide again. What does this mean? This means that what? If you have to look for the HCF of 24 and 36, okay, now we look for a common prime factor that can divide 24 and 36. We start with 2. 2 can divide 24 to give us what? 12. 2 can divide 36 to give us 18. One number can divide again 2. 2 can divide 12 to give us 6. 2 can divide 18 to give us 9. One number can divide again now 3. Now from here now 2 can divide 6, but it cannot divide 9. Okay, so we are looking for a common number that can divide both. Okay, but 3 can divide both of them. 3 divide 6 will give us 2, and 3 divide 9 will give us 3. And over here, no other number can divide both 2 and 3 at the same time without remainder. 2 can only divide 2, but 2 can divide 3, we'll have a remainder. And 3 can only divide 3, 3 can divide 2, we'll have a remainder. So from here, we'll copy out our what? Our prime factors, which is what? 2 times 2 times 3, and we'll multiply them. We'll have 12 as our answer. Okay, thank you for listening. I hope you understand all we have done so far. If you have any questions or if you are still confused in any part, please do reach out to us on any social media platform, or you can send us an email at pcbstudyhub@gmail.com, or on our WhatsApp number, or you can still leave your question in the comment section. I will try as much as possible to get to you. Do share, like, and subscribe to our YouTube channel, and send this video out to your friends or anybody that you know will be needing this video. I'll be coming back with part 2 of this video, which will cover multiples, LCM, and rules of disability. Hope to see you in our next video. Bye.